Welcome. My name is Valentina Marsh. I marked question 25, 27, 33 and 35 in the Standard 2 exam this year. So my team started with question 25, where they had a composite solid that was made up of a triangular prism and a cube, and they had to find the surface area of that solid. So they had 5 squares, the 2 triangles, 2 rectangles, and the total surface area to work out. So the positives, our kids really did know how to work out. They did work out the area of a square quite easily, the area of a rectangle. Sometimes they did a parallelogram, used the parallelogram, not the parallelogram, the trapezium formula to work out the area of that rectangle, which is fine. They did know the formula for the area of a triangle. They didn't always have the right lengths in that. So students often didn't recognise they could just subtract the 8 from the 11 to get 3 for the height. They often use Pythagoras' theorem to work out the height of the triangle, which is fine, just an extra step for them to do. Our kids did well with showing correct working out for their calculations, which was excellent. So they are, us telling them to show their working out was really good. They didn't just give us numbers on an answer on the paper. However, the major problem that they had was the height of the triangle. As I said, that really caused a lot of problems. They often used the height of 5. So the hypotenuse to the triangle, which caused, so that was really the problem. They knew it was half the base times the height. They just had trouble with the height, finding it. So that was one of the biggest issues. The next one was they didn't realise how many faces were in the solid. They often included the whole cube and had 6 faces for the cube. They were missing some sides. They did extra sides. So they had a few issues with knowing what the net of that solid was. Because it had surface area, another problem that we had was it was great that they were using the question and recognising they had to work out the surface area, but they just went to the formula sheet, grabbed the surface area of a cylinder and tried to use that, which was really disappointing because, trying to work out what they thought R and H was interesting. So there was a lot of pi's in these equations. There were also kids that did volume, so they weren't reading the question carefully. So they just did the volume of the solid shape. So as we really need to make sure our kids know the net of a composite solid, so they know how many sides there are in that solid. They really need to make sure they're reading that question carefully, making sure they're doing surface area, not volume, underlining the key terms in the question. They should also make sure they are structuring their solution so that we know what area, because especially if they're doing parts of shapes like different faces, sometimes they break up that front face as 2 trapeziums, again, all fine. So they found that easier, but again, recognise then there are 4 of them because the front and the back, that caused a few issues. So the reference sheet, it was great that kids were using the reference sheet, but in this question it didn't help them because there was none of the formulas, square, rectangle, triangle, are on the reference sheet. So they just don't go, surface area, use the reference sheet, grab a formula and use it to work out the surface area of a solid that it didn't make sense for. So we really need to make sure they know what each of those formulas on that reference sheet are for. So that's one thing that we have to practice. Question 27, they had a garden. So we had a scale diagram where there was a garden in it. They had to use 2 applications of the trapezoidal rule to calculate the approximate area of the garden. They could do the conversions at the beginning, obviously on the diagram, or at the end after they work out area. So the sample answer is there. Positives, students did know how to use the trapezoidal rule, so they did access the reference sheet. We had a lot of kids knew that trapezoidal rule, so really good. We had a lot of kids that broke up the original shape into half, so that, and they could identify the correct H in the trapezoidal rule. So, you know, whether it was converted, whether they said it was 4, or whether they converted it to 20, it didn't really matter. They did identify the correct one. There were some correct conversions. Sometimes they wrote them in the diagrams, sometimes they did them in the calculations. Either, it's just that they weren't always as consistent. The errors that happened was sometimes, even though they used their trapezoidal rule, they just didn't divide it up equally. So sometimes they didn't do equal parts. Sometimes they split it up into 4 parts. Sometimes that was equally done, or sometimes not equally done. And that's where the kids that drew on the diagram, where you could, especially if they did conversions that were incorrect, then we could see what numbers they were using, because obviously there were no numbers on that diagram. So if they were converting and they weren't always consistent, at least if they drew on the diagram, it would have been great. A lot of kids use a counting square technique, where they counted how many whole squares were, how many half squares, then they were supposed to multiply that by 25 to get the area. But often they didn't times it by 25, they often times it by 5. So they didn't acknowledge the trapezoidal rule at all, and they just looked at the squares and recognised that they had done this technique in school and presumed that was it. So conversion of units was also an error, especially if they had worked out the area first and then they wanted to convert using the scale. The problem here was they times it by 5, the area, and obviously they need to times it by 5 squared, the 25. So a really common answer we got was they did the trapezoidal rule perfectly, got an area of 34, perfect, but then they would times it by 5 and not 25. So that was a really common answer that came up. So really, you know, our kids need to know what the trapezoidal rule is. Also, when they're dividing up the shape, if they could show it on the diagram, because you had a scale diagram, making sure our kids use that diagram that's there and draw on it. You know, a lot of them, as I said, divided in half, which was fantastic. Some of them labelled them, which was good as well, because then we could at least, you know, see the skill of conversions on there. However, students that converted at the beginning on the diagram, or whether it was on the diagram or not, as long as they converted at the beginning while they were in lengths, were more likely to get this question fully correct, because they weren't always consistent in converting. So marking them on the diagram was fantastic, especially for those kids that divided into 4 parts. At least then we could see, or if they did unequal parts, we could see what they were looking at and what their conversions were for that section. There were some kids that did the unshaded area and did that converted correctly, which is fine, and subtracted it from the full rectangle, which is good as well. The only problem we found with that method was the distance of the first in one of the applications was a 0, and that always causes kids a lot of grief. So if they did the unshaded area and then subtracted, which was fine, they really needed to make sure that that distance of the first was 0. So we need to practice that with them. Okay. In part B, on the other hand, so even though part A was done quite well, part B was probably the section where students really struggled. They had to answer whether part A was more than, equal, less than the actual area of the garden, and refer to their diagram above with an explanation. So you can see in our answer, if they could draw those trapeziums, it really helped them. So again here, drawing the diagram was one of the things that we would have said really helped them in getting each of these parts correct. So our kids were quite good that they did choose one of the three options. However, they really had a lot of trouble doing a clear enough explanation. One of the most common answers we got was that it was an approximation, that more applications would give a more accurate answer, which is all correct, but not in regards to what our explanation was. So we really need to make sure our kids are, one, reading that question and choosing one of those selections, because sometimes kids just didn't choose selection at all or use both of them, so they weren't clear. There were three clear choices. And also making sure it did say with reference to their diagram, to refer to their diagram. As I said earlier, kids that drew on this diagram were more likely to get better results out of their conversions, also their explanation. If they could draw these trapeziums and it was a clearer way for them to show the excess area that was not in part A. So explanations in this section were the ones that caused the most grief. As we would all explain, as we always say in standard math, they often have trouble with the explanations in the question. Okay, so question 33. 33A was done absolutely fantastic. Our kids were just reading from the graph. They were looking up where N is 40, finding the number of bacteria of 4,000. They did really well at doing that. Most kids could get this one out. There wasn't much, they didn't have to look at the scale. It was reading directly from the graph. So it was a really nice way to start this question. If there was an error, probably the only errors we could see was sometimes kids would subtract the initial 1,000. I think they just thought they needed to do something extra, really. Sometimes we just noticed they didn't have 4,000, so whether they were timesing by, adding 1,000 or, timesing by 1,000 or a power of 10, we don't know what was happening, but there were extra zeros added to it or not enough zeros. So unless they were doing something like that, our learning outcome here would be just to make sure even our kids, when it's an easier question, that they are making sure that they write that carefully, that it's not, something they just go, oh, that's it, and they quickly just move on. They need to make sure that they are accurate in these easy answers as well. Now, 33B, on the other hand, caused heaps of problems. So they had an equation there. They were told A and B were constants. They were told that use a guess and check method to find two decimal places and upper and lower estimate for B. And it must differ by 0.01. So they got 1.03 and 1.04. The positives, as I said, it was done really poorly here. They struggled here a lot. The positives was they did try to do something. So a lot of kids looked at and thought, okay, I'll grab a point from the graph and substitute into the equation, which was great because they were trying to engage in this question. However, if they didn't recognise that A was 1,000, it was in the question that the initial value was 1,000. You could see in the diagram it was 1,000, but what they didn't recognise was that represented A. And because of that, then the guess and check method was a real problem because they were trying to guess values for A and for B, and it just wasn't going anywhere because there was nowhere for them to go because they had it. If you keep changing all these variables, there wasn't enough equations to help them. So in this one, it was about reading that question, recognising that A was 1,000. It did say it was initially 1,000, so this is where it would have helped. We did have some kids that used logarithms to get the value of B, which would have been fine if they're using their 5.3 knowledge, from year 10, and then using the guess and check method to find the value of B. There were some kids, because it said an upper and lower estimate, they were finding an answer and then just plussing 0.05 or minusing 0.05. They were trying to use that error in this solution, but they really had nowhere to go. So it was really difficult for them to get somewhere in this question. They struggled the most. Okay. Now, question 35, you had two cities, A and B, that were normal distribution with a mean and standard deviation. In part A, Yin was in city A with an IQ of 128, and you had to work out the percentage higher than Yin's. So our positives was our kids really did use the formula sheet and use the Z-score. They could work out the Z-score, which is fantastic. We saw a lot of kids draw the distribution curve, which was good because it was a perfect number. So that was clear that they could work it out. The errors that came from it was once they got their Z-score, the percentage breakdown of the Z-score really caused them the most grief here. Sometimes they reversed the Z-score, so they didn't actually accurately transfer it from the formula sheet. Sometimes they did the wrong city, which was really disappointing, or they got the wrong mean and standard deviation. So really making sure our kids read this question, refer to what city they want and the corresponding mean and standard deviation. In this one, because kids drew the curves, sometimes they drew it above the question, sometimes at the bottom, which is fine, but when they're doing them side by side, just making sure our kids label them clearly. So if we've got two diagrams, we know which city they're talking about, because they weren't always clear. Often they were clear, so it was good. We need to make sure our kids use the reference sheet carefully again, just like I had said earlier, because they were not transferring that Z-score formula correctly. So when they were reversing, which was disappointing. And we will need to do a lot of practice with the percentages that go with the Z-score. So that was the one thing that we really need to highlight, that practice that we need to go for each Z-score in this section. Now, 35B was quite similar in a question. You just now looked at the next city, but you were told that there were 1 million people in city B. So they had to calculate the number of adults that would have an expected IQ lower than Yin's. So kids here, they again, positive, the Z-score formula. They could use the Z-score formula. Again, they could draw that curve accurately, really good. And a lot of students, whatever percentage they got, whether it was the correct one or not, did know that they should multiply it by 1 million to get the number of adults. So they could, if their percentage was incorrect, they could often go to that with their incorrect percentage, work out the number of adults. However, as I said last time, the percentage breakdown for the Z-score was what caused the most drama here. Again, the same thing about the Z-score reversed and picking the incorrect city. So really, we need to make sure our kids are transferring this correct formula from the formula sheet, and also the corresponding percentages to the Z-score. We really need a lot more practice with this with our kids. And sometimes there were kids that worked out the percentage and then just ignored and didn't do anything with the 1 million. So making sure our kids are using all the information in the question. So they just ignored the 1 million altogether. So that was really disappointing when they get the Z-score and they get the percentage and then they would just forget to multiply it by 1 million. But overall, it was done quite well. 35C was where Simon moves from city A to city B, and you are asked to form an equation to calculate Simon's IQ score, and you were asked to give it to 1 decimal place. It was worth 3 marks. Positive, so the students really struggled in this section. They had trouble, they knew to use the Z-score formula, so they tried to set one up. They tried to even set up two. What they often didn't understand was that score from city A to city B was, they didn't know how. They thought it was two separate ones. So they sort of go X with an A subscript there and then set up another equation. They didn't know how to put them together. So deriving, they could form the two Z-scores, but actually putting them together and recognising that the IQ was the same in each one was caused them a lot of grief. So as I said, the error was setting up the simultaneous equations. And if they got the simultaneous equation correct, which was fantastic, if they could recognise they were correct, it was great. Then you had two fractions, and they had really struggled solving equations with fractions. Really struggled with equations with fractions, yeah. So we need to make sure our kids are reading that question carefully. Need to, you know, it was asked to form an equation. A lot of kids tried to do a diagram, but of course it couldn't work in this section. They need a lot more practice with solving equations that involved fractions, because that was a letdown. Some kids did try to put the two equations together by just averaging out the means and averaging out the standard deviation, and just did a Z-score that way and solved that. A lot of kids didn't do a lot of work in this section. They could see 3 marks. So we've really got to encourage that our kids actually keep working and just go, I've got to do something. It's something about Z-scores. It's something about an equation. What can I write? Because if they were engaged and started doing some questions, it would be really good. Okay, and that was the last bit for our team. So thank you.